Here we are. Hello and Assalamualaikum for Madam Christina. I am Amira and I am from Group C and I have 3 other members which are Amani, Shifa and Emily. We were given a task for chemical bonding, which is for AB6, AB5E and AB4E2. So we can start from Emily, which is from the class AB6. Thank you.
Hello, my name is Emily and I will present about phosphorus hexafluoride. First, we draw the Lewis structure. We find out that, we know that phosphorus has electron valence of 5 and fluorine has an electron valence of 7. But we have 6 fluorine over here, so we will times the 7 with 6, so we will get altogether 47. But we plus 1 because it is a negatively charged. So we plus 1, so altogether we have 48 electrons. Then we draw the structure. We minus it with 12 bonds because here we have 6. 6 times 2 we get 12 bonds. 12 electrons, sorry. So we are left with 36 electrons. So we just fill in the fluorine charge. And then we will count the formal charge and we will get F is equal to 0 and P is equal to -1. We will find out the number of electron pairs is 6, like I said before, 6, and number of bonding pairs is also 6. Number of lone pair, we do not have lone pair over here. As you can see, we don't have any lone pair at P, so it is 0. The name of the shape is octahedral, like this. It is the shape of this is octahedral, and every angle of every bond is 90 degrees. The class of this is AB6. Next, we talk about the type of hybridization, and it is sp3d2. We know that it is sp3d2 from its electron group. So we find phosphorus at its ground state, and as it has 5 electron valence, so we know that S is filled with 2 electrons while P is filled with 3, so altogether it is 5. Next, we find phosphorus at its excited state. So this 1 electron from the S orbital, we will move it to the D orbital, and then at the D orbital we will add 1 more electron as it is a negatively charged group. Molecule. And then next we find the phosphorus hybrid state. So it is sp3d2 as I mentioned before. When it is like this, the pink one, we fill in the orbitals with the electrons with 1 electron from the fluorine, hexafluorine. So we fill it in, so we will get the phosphorus hybrid. Last but not least, I will talk about the polarity. Fluorine is more electronegative than phosphorus, so the dipole movement will move towards the fluorines. We can cancel out the 2 dipoles here and here and here and here. So as you can see, there will be no net movement, so it is non-polar. So that is all for phosphohexafluorine. Next, it will be Amani's turn.
Assalamualaikum. Now I will introduce with antimony pentafluoride. First, as you can see, antimony has 5 valence electron and fluorine has 7 valence electron. We will multiply it with 5 as fluorine has 5 atoms. And altogether we have 40 valence electron. We will add it with 2 electron as it has charge to negative. So you have 42 electrons. We will minus it with 10 electrons because it have 5 bonding pairs. 1 bonding pairs equals to 2 electrons, so 10 electrons. We will have 32 electrons. This 32 electron will be then distributed in the terminal atom, that is fluorine, and we will have the remainder 2, that is the lone pair. We will distribute the lone pair at the central atom, that is the antimony. Here, the lone pair. So the Lewis structure is like this. We will now calculate the formal charge. The formal charge is valence electron minus lone pair minus half bonding pair. The fluorine has 7 valence electron minus 6 lone pair minus half 2 bonding pair. So we will have 0 formal charge for every fluorine in this Lewis structure. The antimony has 5 valence electron, 2 lone pair and half 10 bonding pair. So we have -2 for the formal charge for antimony. Here is the -2. So next is the number of pairs for antimony pentafluoride. As you can see, it has 6 total of electron pairs. We have 6, 1, 2, 3, 4, 5, 6, and the number of bonding pair is 5, and 1 lone pair. This one lone pair is 2 electron, and then the name of the shape is square pyramidal. Square. As you can see, the base is square, and we have 1 electron up here. So the angle for every bond is 90 degree. Just like Emily mentioned before, it is 90 degree for AB6 too, and it is from class AB5E. Next, antimony from excited state. We will add 2 electrons in the d orbital, as I mentioned before. It is negatively charged with 2 negative, and we will add 2 electrons. So in hybrid state, there will be 3 unhybridized orbital, and in hybrid state we will have sp3d2. So 1 electron from the fluorine will be transferred in the sp3d2 orbital. So we will have this diagram from this orbital. Okay, that's all. Next, polarity. This molecule is polar. We will prove it from the dipole moment. As we all know, fluorine is more electronegative than antimony, so the dipole moment is toward fluorine. So the resultant moment for these two will cancel out, and there will be 1 dipole moment for fluorine. Therefore, there is a resultant dipole moment. So the molecule is polar. That's all from me. Next, we will hear for AB4E2 from Shifa.
Hello, I'm going to introduce AB4E2. We chose xenon tetafluoride as our molecule. This is our model. Okay, as we know, xenon consists of 8 valence electron and fluorine consists of 7 valence electron. But there are 4 atoms of fluorine, so the total number of valence electron of fluorine is 28. 28 plus 8 valence electron of xenon equal to 36. Since there are 4 bonding pair around 8 valence electrons will be subtracted from 36, as there are 4 bonding pair around xenon, so there will be valence 28 valence electron, and we distribute the valence electron around the fluorine. There are 4 atoms of fluorine, 6 valence electron here, here. So 28 will be minus 24, and there will be 4 valence electron left. The remaining valence electron we will distribute to xenon. And then we will proceed to the formal charge. Fluorine has 0 charge, xenon has 0 charge. In xenon tetrafluoride, there are 6 electron pair, 4 bonding pair, and 2 lone pair. The name of this shape is square planar. The angle between the 2 atoms is 90 degrees. The type of hybridization is sp3d2. Okay, in ground state, xenon has 2 electrons in s orbital, 6 electrons in p orbital. In excited state, xenon has 2 electrons in s orbital and another 2 electrons in p orbital. This is because xenon has 2 pair of lone pair. So we can excite this electron to the other orbital. We excite the other 2 electrons in the other 2p group. Since xenon has 6 pair of electrons around it, so the type of hybridization is sp3d2. We are gonna hybrid this section only. Okay. And then xenon tetrafluoride is a non-polar. We can prove it by dipole moment. We already know that fluorine is more electronegativity compared to xenon, so xenon will be attracted to fluorine, and then xenon attracted to here, and here, and then resultant, it will cancel each other. Okay, that's it. Thank you.
Hello. The end. Group 6.
Thank you for watching.
Bye, Madam Christina.
Bye.